I want to make sure we get a really good look at these examples at the beginning. They form the basis for our problem solving. So we're still working with Eric and his odd 4-digit numbers. As an extension, I want to know how many even 4-digit numbers there are, and then where there's no repeated digits. So first of all, even 4-number digits would mean that 2, 4, 6, 8, or 0 would be at the end. That's a choice of 5. And then I've got, remember the first number cannot be a 0. So that would be 1 to 9 choices there. So that's 9 choices for that position. And since we're not worried about repeated digits, I could run 0 to 9 in this position. That's 10 different numbers. 0 to 9 in this position. That's 10 different numbers. And I get to multiply all of these together. So that's 4,500. But if I can have no repeated digits, what does that mean? That means that my end is still the same. I can have 2, 4, 6, 8, or 0. So that's 5 different choices. I still can't have a 0 at the beginning. But let's assume that that 2 was chosen there. So I can have 1 and then 3 through 9. How many choices is that? How many numbers can I actually choose for that position? So this question ends up putting our thinking really to the case, really to the test, because Eric has an interesting scenario. There's a special condition in that the number 0 plays a unique role. I'm going to first start my problem solving by saying that the number 0 is not possible for the last position. It makes it even, so that's correct. In the first position, I have 8 choices, 1 and 3 through 9. I've said I use 2 at the end, so that's 8 different choices. Now for position 2, I have 0 and 3 through 9. That's 8 different choices. And if I take off the 0 for that position, then there's seven different choices for the third position. But it is possible that I have a special number where 0 takes place here. There is one condition in which the number 0 is allowed to be an end term. So one choice for the number 0. And that leaves me with the numbers 1 through 9 as fair game for the first digit. So that's 9 different choices for the first position. And then because I can't have repeated digits, the number of choices simply decreases as I go down. So 8 choices for the second position, 7 choices for the third position. So this is an or situation. I can either have an even number that ends in 2, 4, 6, or 8, or 0. When it ends in 0, then I've got an interesting special case, which is going to involve adding. So now I get to multiply my numbers together. 8 times 8 times 7 times 4 is 1792. And to that, I get to add 9 times 8 times 7 times 1, 504. We have to watch out for those special conditions. I want to make sure I can accent them as much as possible. And now we get to play with the word English. The word English does not have any repeated digits. So that's something that we have to take into account. And there are some unique or conditions in here, so we got to be careful. So I'm building 4-letter arrangements. So 4-letter arrangements, 1, 2, 3, 4, and I have 1, 2, 3, 4, 5, 6, 7 choices. So any letter can be in any position. So it's simply 7 choices for the first, 6 choices for the second, 5 choices for the third, and 4 choices for the fourth position. Okay, if the first and last letters must be vowels. So the first and last letters must be vowels. Well, I only have 2 vowels. The first letter can either be an E or an I, so there's 2 choices for that one. By the time I get to the last letter, there's only 1 choice for that one. So because it was used up at the beginning. That means my middle position, I've got 5 choices for the second letter and 4 choices for the third letter. Now, if the first letter must be an E, if the first letter must be an E, do I have a choice for that? There's only one E, so there's only 1 choice for the letter E. And then I've got 6, 5, 4 choices left for the other positions. The word must contain G. Now here's an interesting one that I wanted to work out in a little bit more detail. If the first word must contain G, G could be at that position, or that position, or I'm going to have to make my page longer. G could be at position number 3, or G could be at position number 4. So the word or the condition or, which was not explicitly stated, we know we have to add. So there's only 1 choice for where the G has to go in any particular location, but my other positions are 6, 5, 4. 6, 5, 4, 6, 5, 4, 6, 5, 4. And 6 times 5 times 4 is 120. There are 120 different ways of getting that word, 120 different ways of getting that word, 120 different ways of getting that word, 120 different ways of getting that word. And we're going to add that up. 4 120s, or 120 plus 120 plus 120 plus 120 is 480. Let's get the practice in on this lesson. We needed to look at all of the examples. I hope that was helpful for you. Let's work.